All right, so I'm going to assume that you spent a lot of time solving equations last year and solving one-step and two-step equations especially. So I'm going to whip through this pretty quickly and introduce you to what's called set notation so that you understand what you need to do there. So remember, when we're solving an equation, the ultimate goal is to get the variable alone. And to get the variable alone, we're going to undo whatever operations are happening to it. So in the first one, we are subtracting 6 from x. So if we want to get x alone, we're going to do the opposite of that, which would be to add 6 to both sides. Now, when I show you these, the way that I do the notes are always the way that I expect you to do your homework and your work in the classroom and on your tests. So even if you can mentally guess at what these are, you should practice showing the work the proper way and following with what I have here. So the negative 6 and the positive 6 will cancel. Negative 12 plus 6 would be negative 6. Now this isn't good enough for Algebra 1. We're going to put these in set notation. Now set notation is just a way to fancy this up. It's a more formal way. So what we say is that I solved for x and x equals negative 6. Okay? And then we put brackets around the outside. That's not really how you read it, but it's x such that x equals negative 6. X such that x equals negative 6. I found x, and it's such that, in this particular case, x equals negative 6. It's like you need some tea and some coffee cakes with it. X such that x equals negative 6. But you will be expected to put these all in set notation. So it's not difficult. After you do it 6 times, then you'll know how to do it, okay? Now, when you're doing a one step like this, you can't work with this double negative. So we know that if two negatives are next to each other, I like to say make it happy. So this is now really k plus 3. So if we want to get k alone, we're actually going to subtract 3 from both sides. So we get k, which k equals negative 9 minus 3. So remember, that's really like negative 9 plus a negative 3, which gives us negative 12. So k such that k equals negative 12. Set notation. All right, here we're getting 8 times t. The opposite of multiplying by 8 is divide by 8. We're not going to use the division sign. We're going to use a division bar in this case. So we get t equals negative 7. T such that t equals negative 7. Number 4, m is being divided by negative 7. So the opposite of dividing by negative 7 would be to multiply by negative 7, which when I multiply a fraction by a whole number, I put it over 1. And we multiply this guy by negative 7. So what happens here is these two negative 7s cancel. Oops. Top to bottom, they cancel. So we're left with just m. And negative 21 times, 21 times negative 7 is negative 147. So m such that m equals negative 147. All right, so here we're dealing with a fraction. These two things are the same. However, they're just shown differently. So if you're dividing by a number, you can multiply by that number. Or if you think about it this way, if you have a denominator that you need to get rid of, then you multiply by the denominator. So we're still multiplying by the denominator. Those will still cancel, and you're still left with 1x. Now you can write 1x, or you can just write x, since that's what we want to get to anyways. And negative 4 times negative 2 is positive 8. A negative times a negative is a positive. Okay. All right, moving on to 2 steps, because I know you're bored by the 1 steps. When you're undoing or doing 2-step equations, you need to make sure you undo addition and subtraction first, because we're basically doing the order of operations backwards. So undo addition and subtraction first. And remember, we're still trying to isolate the x. So this is multiplication. We're not going to do that. We're going to undo this addition. And when we undo it, that means we need to subtract. So the opposite of adding 3 is to subtract 3. 23 minus 3 is 20. Now 5 times x equals 20. We want to get x alone. X is being multiplied by 5, so the opposite of that would be to divide by 5. x equals 4. And we put our x such that x equals 4. Number 7, another two-step equation. Why don't you pause it and see if you can do this one on your own. Okay, let's see how you did. So we want to undo addition and subtraction first. This one is very similar to this one. So the opposite of subtracting the 17 would be to add the 17 to both sides. All right, 7 is being multiplied by m, so the opposite of that would be to divide by 7. So we can get these 7s to cancel, and we get 11. M such that m equals 11. Okay. Next, what to do with fractions, kind of. Okay. There's two ways we can approach fraction problems. I'm going to do both ways, and then you can determine. But in this particular case, I would probably focus on getting rid of the fractions. Okay, it's not the only way. So if you see a denominator in a problem, what you can do, as we wrote on our Cornell sheet, would be to multiply every term. Where do we write that? Multiply every term by the denominator. Okay, so that's what we're focusing on here. And so the denominator is -4. So we're going to multiply the 8 by -4, the -12 times -4, and the k over -4 times -4 over 1. So the part that has the fraction in it, I always multiply by a fraction, so I can clearly see what's going on. So 8 times -4 is -32. -12 times 4, sorry, -4. A negative times a negative is a positive 48. And then these -4s, the one on the top and the one on the bottom, will cancel, and you'll just get plus k. And then all your fractions are gone. In order to get k alone, right now k is being added to 48, so to undo that, we subtract 48. Be careful here. -32 minus 48, is this do leave, change, opposite, -32 plus -48 is going to give us -80. Now we have a small problem. When you do set notation, the x has to be on the left side. So we're just going to flip this over. K such that k equals -80. You absolutely have to have the variable on the left. Right here, actually. Okay? You can't have the variable on the right, so just flip it over. No big deal. Okay? Next. Now, the other way you could handle a problem like this would be to move the 4 over first and then deal with the 1/8. So they're both okay. If you like to get rid of all of them at once, you can do that. Or if you rather move some things first. So we can undo addition and subtraction first. And the opposite of subtracting 4 would be to add 4. And then we have this denominator, 8. So again, if we have fractions we want to get rid of, we multiply through by the denominator. We have one term on the left side, which we multiply, and one term on the right. In this case, we had 1 on the left and 2 on the right. They all have to be multiplied by the denominator. Okay. So over here, the 8's cancel, and you're left with 1p, or you can just write p. And 14 times 8 is 112. So p such that p equals 112. Okay. Why don't you pause the video once again and see if you can do 10 and 11 on your own. Okay, let's see how you did. So we've got multiplication going on here and subtraction technically. We're adding a -4. So sometimes people get confused when the x is on the right side. Don't worry about that. We need to move things away from the x. So this -4 has got to go first. So the opposite of the -4 would be to add 4. 4 plus 4 is 8, and we're left with the 8x. Now again, we're still getting x alone, so we need to divide by 8 because x is being multiplied by 8. The opposite of that would be to divide by 8. So those cross out, we get x, and 8 divided by 8 is of course 1. Did you remember that for set notation you need to move the x to the left side? It cannot be on the right side, so just flip it over. Not a big deal. Okay, on 10, you had two options. You could multiply through by the fractions like we did, or by the denominator like we did here, or you could move the piece first and continue through like this one. I'm going to do it where we move the 4 first. So we're going to add the 4. So we get 7/8 p equals 14. Now, we are multiplying through by the denominator. So we multiply by 8 over 1 and by 8. Now this is very similar to this one, but it's one difference is that there's a numerator here of 1 and this numerator is 7. So that's going to require an extra step. So we get 112 equals. The 8's cancel, but then we're left with 7p here. And so we still need to get the p alone, which in this case the p was already alone because it had just the 1 and the p. So we have to do the opposite of multiplying 7 times p, and that would be to divide by 7. And 112 divided by 7 is 16. So p such that p equals 16. A few more problems solving with fractions, equations with fractions, okay? So I want you to pause once more and do 12. You don't need to do 13 and 14, but pause again and see if you can do 12 on your own. Okay, let's see how you did. So again, you got two ways you can do it. I'm going to move the 8 first. So we are subtracting 8. We get 2/3 x. These drop out equals, this is -6 minus 8. So -6 plus a -8, which is -14. Leave, change, opposite. Now, we've got to get rid of that crazy denominator. So multiply by 3 over 1, multiply by 3. The 3's cancel, but you're left with 2x. And -14 times 3 is -42. All right, final thing, we want to get rid of the 2. That's multiplication, so the opposite of that would be to divide. So we get x equals -21. X such that x equals -21. Okay? Very similar to the last one we just did. Now 13 and 14 are going to be started the same way. We have a fraction, there is a denominator, so we're going to multiply by the denominator, just like we have in these other fraction problems. So the denominator is 9, so we multiply this side by 9, we multiply this side by 9 over 1. The right side is no big deal. -6 times 9 is -54. But on the on the left side, you have to be careful because this 9 in the denominator is going to cancel with this 9 in the numerator. And all that we're left with is this p minus 15. That's it. Okay. It's actually easier than this problem because now we just need to solve for p, which p, we're subtracting 15, and the opposite of subtracting 15 would be to add 15. So we get p equals -54 plus 15, which is -39. So try 14, following similar steps to 13. Go ahead and pause the video and see if you can do that one. All right, so the denominator is 5, so we multiply this side by 5 to get 30. We multiply this side by 5 over 1. And once again, these 5's are going to cancel completely, and all you're left with is 4 minus 2d. Now this one's a little different from this one because we have a number in front of the variable. There's no number in front of the variable here. So we do need to get rid of the 4 and the -2. The 4 is the addition and subtraction piece. It's a +4. So we're going to undo that by subtracting 4 from both sides. So we get negative 2d equals 30 minus 4, which is negative 26. I'm sorry, positive 26. And then we want to get d alone. So it's being multiplied by negative 2. The opposite of that would be to divide by negative 2. So we get d equals negative 13. D such that d equals negative 13. So we have this fear of fractions, but when you're solving an equation, it's really simple to get rid of the fractions in that first or second step, depending on when you determine you're going to do it. And then you don't have to deal with them, okay? So put your fear of fractions aside and just multiply through by the denominator.